Perfect. Thank you for joining me, Shravan and Lavanya. So we have been discussing about Spark, and this is our fourth session. Till yesterday, we were talking about what is Spark platform, and what is a Spark driver, what is Spark executor, and how Spark reads your RDD as a partition, how you create an RDD programmatically using sc.parallelize, and how you can create an RDD from a text file with sc.text file, and what is a map, what is a flat map. And you also understood how you initialize a function with a map, with a lambda function, initializing a variable and then giving the business rule within the function. Now, after considering understanding the map and flat map very clearly, we are going to discuss about filter today. Okay, now if you understand each and every functions, okay, in later stages we will go into the transformations. Okay, these transformations are so important that they are the key of your Spark. Understand carefully. Let's start from the filter point of it. Now, the filter function is used to remove elements from an RDD that don't pass a certain criteria, or put another way, only keep the elements in RDD based on the predicate. Okay, if the predicate turns to be true, okay, the filter criteria met. Record is passed on the transformed RDD. I repeat, filtering is nothing but you have 10 records, and in that 10 records you're filtering out only the even numbers and removing the odd numbers. From 1 to 10, the even numbers are 2, 4, 6, 8, 10. So your Spark RDD will pick those 2, 4, 6, 8, 10 and put them into new RDD. The new RDD is nothing but transformed RDD. Okay. The way how you can do that is, you'll have to first create an RDD and then apply the function on top of it. So let's do the filter operation now. So I'll launch PySpark here. Let me see if the session is recording. Yeah, it's recording. Perfect. Okay, this is the Spark context with Python. So I'll create RDD numList equal to sc.parallelize, and on top of it I have how many how many as a PPT. I have 5, 7, 10, 11, 14. I can take anything, not a problem. 5, 7, 11, 14. Done deal. Okay. Now RDD numList dot map function, or I say RDD transformed equal to RDD numList dot map function. You have lambda function, you have x. Okay, x greater than or equal to 10. Okay, you can also give space if you want, but please be very careful. Okay, that's it. Now RDD transformed dot collect. See, false, 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 false. Five is not true. Okay, 1 minute. Why did I apply map function? I have to apply a filter function, right? Okay, I'll do the same thing, but what I'll do is I'll say filter. Okay, I will say filter, and I don't want lambda also. Your lambda function you can use only for maps, but no, I can, yeah, lambda function must also be used. Sorry for that. Okay, filter lambda, yeah. RDD object has no attribute filter. Let me do it from beginning. I think I messed it up. 1 minute, guys. This is perfect. And RDD transformed equal to RDD numlist dot filter lambda x. Let me see if that works. Is less than or equal to 10. Is filter small case? Yeah, it's small case. That is a problem. Let me correct it here also. Filter is a small case, not uppercase. Okay, sorry for that. Okay, now if I say RDD transformed dot collect, you might have to be very careful, guys. This kind of things will happen. See, 5 and 7 are less than or equal to 10. Like that, if I say greater than or equal to 10, let's see what happens. Eleven, 14 are greater than 10. That's what it is. Now you understood how filter works. The only mistake what I made is I have used uppercase F instead of small f. Okay, that's what it is. Now let's take months January, March, May, July, September. Now you are doing RDD equal to sc dot parallelize. Okay, and then in that you are using the lambda function. Okay, for lambda function you are passing a filter, but you are taking the name is this one, for which length of the name is greater than 5. Okay, if you observe carefully, 1 2 3 4 5 6 7, it has 7 letters length. 1 2 3 4 5, this is 5, this is 3, this is 4, this is more than 5. Like that, it has to show you the length of the month which is greater than 5. Let's do that now. This is nothing but filtering. Okay, okay. Now RDD months equal to sc dot parallelized of months. Is that correct? Yes, it's correct. Okay, now RDD months filtered equal to RDD months dot filter function. Okay, month of length is greater than 5. It's month. Okay, month of length. Okay, lambda function. Yeah, I missed a lambda function here. Sorry for that. I have to apply lambda function. Lambda is very important in Python. Without lambda, you cannot do anything in PySpark. It's different scala, which I'll show you later. Greater than 5, and then dot collect. Okay, I won't collect it right now. I'll do till this point. Now rdd months filtered dot collect function. LAMBDA, lambda spelling mistake or something. We did a mistake there. Let me check. Lambda function. Length of name. That's a problem. Not month of length, it's length of month. It's length of month. Okay, not that was my fault. I don't remember any syntax, guys. I always refer it. Okay, so there's no hard and fast rule that you have to remember all the syntax. Okay, I never remember syntax. I know how it works, so I just have it in my repositories. Okay, do not worry about it. You need not have to remember the whole syntax. So if you remember how it works, you can make it out at that point. Okay.
Amar, you declared it as months.
No, that is fine. See, this bit is fine. This bit,
Not,
this
not the one. You said months. Can you check up?
I know what you're talking about. See here.
The first statement that you said where you declared January, February, and other stuff.
See here. You got it?
Yeah, you said months there, right? MONTHS.
That's what. See, this is the initial thing. Okay.
Mm-hmm.
This is done. Okay. The second thing is, do you see here? RDD months. RDD months is small uppercase M is equal to SC dot parallels of months. Means the information which you have given in the top line will be fed into RDD because I'm parallelizing from that one. Clear?
Mm-hmm.
Is that okay for you now? Did you understand what I did?
Yes, yes. But when you're doing RDD months filtered, why are you giving month instead of months?
See,
Lambda month.
that's what I'm telling you. See, now this is my RDD. I already I shouldn't be worrying about this one because this is my input. Okay, this input is now an RDD with this syntax for this one. So all I have to do is I have to do apply transformation on this bit. Okay, now that's the reason why I am doing filtered equal to RDD months. Okay, this is the filtering transformation which I am applying on this transformation. So RDD months dot filter. Okay, length of month greater than 5. If I say correct,
Is it,
yeah, go ahead. Go ahead.
it's lambda month or months?
You're talking about this one?
Yes.
Okay, no. Okay, I'll clear your doubt. 1 minute, guys. The spelling mistake here. The syntax error. I have to close this bracket. I didn't close it. I'll do once again. Bear with me. months is fine. RDD months filtered, RDD months equal, this is also fine. And then RDD months filtered equal to length of this one greater than 5. Okay, this is also fine. Now RDD months filtered dot collect. Do you understand? The name doesn't matter there. That is just as told earlier. Every time when you invoke a lambda function, you initialize an argument. Once you initialize a variable, you give a colon. After that, you initialize what your variable has to do for that function. Now,
Yeah. Do we have do we have something like, because we're using multiple variables here? I mean, do you have something like the variable's memory gets deallocated once you?
that is what it is, right? That is what immutable and mutable concepts. Immutable means throughout your functional programming, once you create a integer or string or any record that is mapped to a variable, you cannot reassign it until unless it is transformed. That is val and var. I told you very clearly importance between immutable and mutable.
Okay, get it. I got it.
Okay. So if you want, you can also do like this. You got the same thing, right? It doesn't matter what you give there. All it matters is, are you initializing a variable? Are you putting a colon? And the right side of the colon, are you giving your business functionality, what it has to be done on each element? Okay. Now this x, okay, this x is nothing but this one, this one, this one, this one. Now x length of is greater than 5. First it will go and take January. January is greater than 5. Yes, it will save in memory. Okay. It will go to February. Yes, this is x. X is greater than 5. Yes, it will save in memory. March, it is equal to 5. No, it will save in memory. April, it is also equal to 5. Save in memory. May, less than 3. False. Save in memory. June, uh, less than 5. Save in memory. Now, I have two truths and the rest are all false. That is the transformation. That is in-memory transformation. When I say collect, that is an action. So the action has to be written. Now it releases all the memory and does the actual work. That's what I was trying to tell you from day one. All the transformations are in-memory transformations. Once the transformation is turned into action, it becomes written to disk, which is physical. Till that point, everything is in memory. Now, any available function that performs evaluations on text strings on arrays could be used to filter or for a given result. That's perfect. Now let's talk about distinct. Now, distinct removes duplicates elements from an RDD. Very simple. Okay. RDD big list is equal to sc.parallelize. As we have been familiar now, I'll copy and paste it. Okay. I'll not waste any time. See here, RDD big list equal to sc.parallelize. Done deal. Check if it is created properly. RDD big list dot collect statement. Spelling mistake. I always do this. Perfect. I appreciate it. I got it. Now, if you see here, if you're applying distinct, what it will do is it will remove all the duplicates. Duplicates means 5, 5, and 14, 14, 21, 2. That's it. Okay. So now, when it remove duplicates, what I'll get? I'll get 1 4, I'll get 1 5, I'll get 7, I'll get 11, I'll get 2, I'll get 4, I'll get 21. Okay, let me check that one. Remove all drawings, go to pointer. Okay, copy, paste. I shouldn't have done that. First this bit, okay, and then this bit. You can practice it. All the slides are with you now. You got 2, 11. Are they in ascending order? They are not ascending order, right? I can say uh,
Are we not able to view your screen?
everyone. Is that same problem with everyone? Guys, is the problem with everyone?
Until now it was okay. All of a sudden it got stuck.
Lavanya, is the same problem with you? 7 no means
No, it's not.
are you're able to see, right?
Yeah.
Okay, right, perfect. Shilpa, I think a problem with you only. Every other is able to see it. Okay, this is distinct. Once you did distinct also, you can apply order by on top of distinct. Okay, that I'll show you a little later. Okay, now distinct means it has eradicated, it has you have duplicates, right? It has filtered other. Sorry, I was yawning. So what it has done is it simply distinct. It provided distinct of it. Okay, distinct is but 4, 5, 7, 11, 12. Okay, that's what it is. You understood distinct also. Now, basic Spark actions. The basic Spark actions means what is collect, what is first. Till now we were discussing about transformations. All the transformations will be done in memory processing, but actions are physical. So once the transformation is performed, for the transformation after performing into action, it would need it would need to be using some resources. That's what it is. Okay. Now, as we have already seen, the collect function returns the entire RDD on which it has run against. Yes, that's correct. I don't know why this font is like this. I always use Georgia. Let me change it. Yeah. Now, one minute, guys. 1 minute. Yeah. You already know that collect statement will give the results of the transformation that is applied against the dataset. That's right. Now, in addition, the first function returns the first element in an RDD, right? The take function, let me split it out. The take function allows a specification of number of element and returns the number of elements when executed. Okay. Below are the examples for functions. Now, if you see here, observe carefully. Observe carefully. I am creating an RDD sc.parallelize. Okay. Now, if I say RDD numList dot collect, given everything, right? RDD dot numList take off 1, only 1. Okay. If I say take off 2, it does 2. If I say take off 3, it takes 3. If I say take off 4, it takes 4. Okay, that's what it is. Clear? Collect, take. We understood that. Now, if I say first, it given the first value. Okay, that is what the actions are. Okay, you understood collect statement, you understood first statement, you understood take off statement. That's it. Now count. If you say here rdd numlist dot count, 4 records. Okay, for example, if I change this one into 14, 15, 16, 17, 18, 19, 20. Now if I say, see, I got 10. Okay, that's what it is. That's a count like that. In the case of a file that contains lines of text, the count would return number of lines. Okay, for example, if I say rdd amarnath.txt, amarnath equal to sc.parellize users hadoop thoughtworks amarnath.txt. Okay, that's perfect. Parell parallelize. Oh, sorry, it's a text file, right? I shouldn't be using parallelize. Sorry, it's a text file. So when you are using text file, you need to use sc.text file. I told you earlier, it was my fault. sc.text file. Okay, now rdd amarnath.collect. Just check the transformation, check if it has taken. There is a spelling mistake. Not users, it's user. Now if I say rdd amarnath.collect, it has given me. Now if you say rdd amarnath.count, the number of lines will be number of, it has 5 lines. Okay, got it? If you observe carefully, 1, 2, 3, 4. Okay, the reason why it gave 5 is there is one space between the uppercase and the lowercase. Okay, I mean the top one and the bottom one. That's the reason why it has given 5 lines. Okay, now this is also done. We understood the count. Now reduce, very important. Without reduce you can't do anything in the Spark. You have to be very clear about it. The reduce function aggregates the element of an RDD. Okay guys, I have an assignment for you. One, two, three. How many Spark sessions did I give the session 5? Session 5. Flume session 1. HBS deep dive. Yeah, this one. I am going to repeat this again for you, but if you are curious enough, you can spend time on this video. I made it very nicely with practical examples. Okay, I can explain that once again, but if you can watch it when you have time, it would be really great. Okay, now reduce by key, combine by key, aggregate by key are so important in Spark that if you understand this one, how your journey of Spark will be straightforward and simple. Now, reduce is nothing but it is aggregating the elements of an RDD using a function that makes two arguments and returns one argument. Okay, argument number one, argument number two. Okay, this is the lambda function. Earlier, you have applied an argument called map. Now you are applying an argument called reduce. Okay. After submitting an argument reduce to a lambda function, you will initialize a variable. That variable is this one. And you have the business function on the right side of the colon. This is the colon. Oh, sorry. This is the colon and this is the function it has to apply. So what happens? This is A. This one is A. Okay, before that I want to explain something. Let me take a paint and write that the way how it works. Paint light. I have 0, I have 1, I have 2, I have 3, I have 4, I have 5. Okay, now come back. Okay, now 0 plus 1, 1, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. Okay, now here when I say a comma b, my a is equal to 0, b equal to 1. Okay, let me show you. I have 5 7 11 5 7 11 14, right? 5. I'll erase this 1 minute. I have 5 7 11 14. So here a is equal to 0, b is equal to 5. Understand guys, very important, very important. So initialization variable will be 0. What is 0 plus 5? It is 5. Okay, 0 plus 5 is 5. Now a is equal to 5, b is equal to 7. Okay, what is 5 plus 7? 12. So now a is equal to 12, b is equal to 11. What is 12 plus 11? I know 12 plus 12 is 24. So 12 plus 11 is 23. Now a is equal to 23, b is equal to 14. Okay, what is 23 plus 14? 4 plus 3 is 7, 2 plus 1 3. So 37. What is the final result? Final result is 37. That is reduced by key. Do you see that? You got 37. Now, let me do the same thing now. C dot parallelize. Sometimes I get lost so easy, man. Seriously. 5, 7, 11, 14. Okay. Spelling mistake. P-A-R-A-L-L-E-L. Let me see the spelling correctly. P-A-R-A-L-L-E-L. P-A-R-A-L-L-E-L. I'm sorry for that. L-L-E-L, man. Okay, that's perfect. Now, if you see RDD reduce dot reduce function, you have lambda function. Okay, L lambda a comma b colon a plus b symbol. Okay, 37. You got it right. That's what it is. Very simple. Did I understand the reduce function? Now, because of the parallelized nature of RDDs, the reduce function does not necessarily process RDD elements in a particular order. Okay, therefore, function used with reduce should be both commutative and associative. Commutative means keeps. What is commutative meaning? Commutative means it keeps actioning, it keeps doing the work continuously. That is commutative. Okay, did you understand reduce by key reduce very nicely, guys? See the difference of reduce and reduce by key. Okay, it doesn't take it. Okay, okay. Now did he reduce dot collect statement? Same thing. So reduce by reduce by key. Reduce function added the results, but reduce by key has not added the result. Do you know why? You didn't initialize a key. You just gave values 5, 7, 11, 14. For this 5, 7, 11, 14, which one is the key, which one is the value? When you asked me to reduce by key, I need a key, and with reference to that key I'll reduce it. But you have not given me any reduce. You have not given me any key. Okay, we'll discuss about reduce by key little later. But you have to understand what is reduce function. Reduce function, having said, it will take two arguments and it will give one argument as a result. Okay, takes two arguments and returns one argument, iterating through them until one single value is achieved. That's what I'm telling here. So it has done the iteration till the end where it has got one result. Okay, 0 plus 5 is 5, 5 plus 7 is 12, 12 plus 11 is 23, 23 plus 14 37. That is how your reduce has taken two things and apply the transformation. Okay, this one is very clear now. Shilpa, any questions till this point? I hope I.
Yes. When you do RDT numlist dot reduce with lambda a comma b colon a plus b equal to greater than 37, as in with a condition, will it return true or
Madam,
false?
madam, this is the result. This is the result.
No, my question there was, can you give a condition as well?
What condition?
Like again, is equal to greater than 37 along with that statement?
No, 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 no. Reduce function. See, this one is actually.
Yeah, I understood. Reduce has given us an output of 37.
Mhm,
So what I'm saying is, in the same question, I mean, same statement above,
mhm.
is it, can we give a condition as well?
Uh, not immediately, because reduce function it just adds it. It has done that work there. It cannot do anything on top of it. Okay.
Okay.
So you cannot do it for this reduce. If you use reduce by key, okay, you have a key
Mm-hmm.
and you wanted to apply the
Mm-hmm.
sort by, filter by, distance by, order by, or any condition on top of the key. Okay. Here you don't have key. There's no key, there's no value. Okay, we'll talk about key and values tuples little later. The next slides comes there. Okay,
Okay.
perfect.
Good.
That's good. That's good. Now, let me tell you a few things. Commutative means to move around, which implies that order of things are done in should not matter. For example, 5 plus 7 equal to 7 plus 5, 5 into 7 equal to 7 into 5. Okay, now the function that is not commutative can return different results each time it runs. For example, 5 divided by 7 does not equal to 7 divided by 5. Okay. In Spark functional programming, you always have to design, you always have to define, you always have to understand how your transformation is going to give results if it is a commutative. 5 plus 7 equal to 7 plus 5. Agree, I appreciate it. But 5 divided by 7 is not equal to 7 divided by 5, which you have to think logically when you write your transformation. Okay. So, a function that employ division would not be commutative anytime. Okay. Addition is a commutative. That's the reason why here we have told very clearly. Therefore, the function used must be both commutative and associative. 5 plus 7, 7 plus 5. Let me show you something here. Okay. This thing, if you count this one with this one or this one with this one, it is same. If you count this one with this one or this one with this one, it is same. If you count this one with this one or this one with this one, is both the same. Okay. But if you do 5 by 7 divided by 5 by 7 and 7 by 5, it's not same. So that is what I was, that's where I'm coming from. Okay. Very good. Next thing, save as text file. This is also part of collection. Means you're collecting all your transformation results and you are trying to save them. Okay. Now let me show you. The save as text file function writes the content of RDD partition to a specified location. Okay. For example, your HDFS location, which is nothing but RDD numList is equal to save of text file. Let me show you that right now. Okay. Now if you go and check, okay, see how many partitions it has given. Do you understand that? Now if I say Hadoop fs minus cat, see 5 7 11 14, it has saved as a text file. That is the importance of save as text file, because sometimes when you apply your transformations you will have to save the results somewhere else, right? That for a reason you use save as text file. Success can be verified using a typical tool from the command line GUI. Okay, In this case, in our example, we could see Hadoop fs minus ls command to verify return successfully. Do you see this one? Success. And if you copy this one and say Hadoop fs minus cat, paste it here. Yes. It is success file. Okay. That's 0, however. But it has written everything. That's why it shows success. Okay. This is done now. Let's move on to next bit. Transformation versus actions. Lazy evaluation. Okay. Give me a second, guys. Okay. Now let's come back. Transformations are very lazy in Spark. Okay. Meaning they do not actually perform any computations until an action is performed. Till you give action, everything is in memory processing. Okay. Now, lazy evaluation prevents the processing of unneeded data. When a transformation alone is applied to RDD, initially nothing happens. Okay, for example, RDD RDD just keeps track of all.
It's 6 o'clock.
That's okay. RDD just keeps track of all transformations applied and will execute them when necessary. Okay, for example, if you see here, RDD is equal to this bit. All right. You are applying first a map function, right? Very good. After applying a map function, you are filtering it out the length of the words greater than 4, right? These 3 steps are transformations. So till these 3 steps, it is in memory. The actual work is not done. It is just memorizing what this guy is asking me to do and how I can do it. If at all he asks me to do an action like collect, save as text file, take off 5, take off 4, or first value or last value, that one. If this guy asks me to do something like that, I must be ready to do that action. Till that point, I'll organize everything and put in my memory. That's how it thinks. Okay. Now, let me show you something. Now, let me go to Spark again. Okay. If you see here, RDD Amarnath, spelling mistake, Parallel. Perfect. RDD Amarnath dot collect statement. Okay, very good. This is wrong. This is not parallelized. It's 65. I did the same mistake as I did earlier. Sorry for that. Sc dot text file f uppercase. Okay. Now if you say rdd amarnath dot collect statement, it gave you this one, right? Now if you say rdd amarnath, I am applying first transformation is equal to rdd amarnath dot map function. On top of it I have a lambda function, and I have a, and a dot split. Okay, I'm splitting with space. Okay, this is one bit. Now rdd amarnath 1 dot collect, just to checking the what's happening. Okay, now each letter is splitted. Now on top of it, if you see here, this is first thing. Now rdd amarnath 2 is equal to rdd amarnath 1 dot map function. On top of it I have lambda function. I say a, and a of length is greater than 3. Okay, let me check if my syntax is correct. Length of a, not a of length, it's length of a. Length of a is greater than 3. Okay, now rdd amarnath 2 dot collect. One minute, it shouldn't be giving like this result. Something is messed up. Yeah, filter, I didn't filter it, I used a map function. That's the reason it mapped results. But if I use filter function, it will filter it out and give it to me. Okay, let me show it with filter function. Okay, rdd amarnath 2 dot collect. So it has given all the strings which are greater than 3. Okay, but if you see greater or equal to 3, if I make it greater than 5, let's see what happens. rdd amarnath 2 dot collect. It is still showing 3 digits, not sure why. It should ideally filter out everything, right? Yeah, they have applied flat map and I have applied map. I'll show you the difference now. Guys, see, I told you the difference between map and flat map already. So if you apply a flat map, okay, if you apply a flat map, it will flatten the whole data. Now this one is one element, this one is one element. Okay, within this element you have array, right? Instead of it, if I apply flat map, see what happens. Just observe, guys, just observe. I'm going to Amarnath and applying flat map here. Okay, I'll apply flat map and show you. Now see rdd amarnath 1 dot collect. So the whole set is now, it started here and ended here. So one element in that you have arrays. I'll apply this filter function on top of this one now. Okay, now I should get correct results. That is the confusion part. See, it has given only 5, greater than 5. It has not given anything. But here if you see, it has given some wrong results because you are applying the transformation on top of a mapped results. Map is nothing but it has this bit. Okay, in this bit if length of A is greater than 5, see 1, let me take a pen. The way how it's interpreting is, this is 1, not here, not here, yeah, this is 1, this is 2, this is 3, this is 4. Again 1, 2, 3, 4, 5. Okay, so if you see here, this bit is greater than 5, length of the whole element is greater than 5. And now if you see here, this is 1, this is 2, this is 3, this is 4, this is 5, greater than 5. So this also it has taken as 5. Okay, now if you see here, this is 1, this is 2, this is 3, this is 4, this is 5. So it has given this one also. One thing you need to understand, for you the transformation must be applied on each word, or it's not each word, how I can say, it's not a sentence also, group of words, your words which is greater than 5. For example, wanted, training is greater than 5, so I want this kind of things, not this one. When I did, I'm sorry, when I did the filter function on a map function, it gave me a different result. When I did a flat map and give a filter function, it gave a different result. You have to understand that one. So Spark will do anything, but the way you ask it to understand depends upon how you are flattening it, how you are making your preparations for the processing work. That is very important. Did you understand the difference and the mistake what I made, everyone? Earlier what happened, when I applied a filter function with elements greater than 3, and what happened if I apply flat map and then applied filter on top of it? Any questions? Any questions? Guys, are you with me? Any questions? Lavanya and Shilpa, Shravan? What about you? Shilpa and Lavanya? Very good. Once again I repeat, a flat map flattens the whole data, whole elements in the data set which we discussed yesterday. I have very clearly shown you the mess what happens if you apply a transformation before flattening the data, and a result what happens if you apply before flattening the data. Okay, now in the above code the two transformations were applied, one is flat map and then filter, but it was not until the count action is called the RDD runs through various transformations. Okay, I've shown you that. Count is a transformation, correct is a transformation, take off 5, take off 10 is a transformation, first is transformation. Okay, now multiple RDDs, unions and intersections. Here what's happening is, to combine two RDDs you use a union function. This transformation is applied to an RDD and takes second RDD as an argument. Okay, if you see here, this is your first RDD, this is your second RDD. Now if you union it, what is going to happen? Okay, now let me take this one, copy it here. Why it is closed? Now this is my first transformation, sc dot parallelize. This is my second transformation. And if you see here, RDD combined equal to RDD numlist of union numlist of 2. That's it. Now if I say RDD combined dot collect, it will give me the whole result of RDD1 and RDD2. Oh my god, I'm sorry, I copied it wrong. See, 5, 7, 11, 14, it gave everything, right? So this is union. You are doing nothing but your RDD numlist is one RDD, your RDD numlist 2 is second RDD, your RDD combined equal to RDD numlist dot union of 2. That's it. Very simple. Clear? Now, in other case, an intersection is decided, a transformation in which one value that exists in both RDDs makes into the output. Okay? If you see here, 5 and 14, because 5 and 14 are the only one that is common here. This is 5, this is 5, this is 14, this is 14. It intersected. That's perfect. Now, if you see here, you can apply a union function like this, and you can apply a intersection function like this. That's it. Now, named functions. Named functions are nothing but, these are very important. These are like calling your constructors, objects, case classes of Java syntaxes. This will be confusing you a bit. But we must do it. It is very important. I'll stop it here now. I don't want to bombard your head. We understood a very important concept today. We applied reduced transformation. We understood filter transformation, and we understood actions like save as text file. And you understood why transformations are very lazy. What is the difference between transformations and actions? And I have shown you count, collect, first, distinct, everything. Okay, that's all I have for today. If you have any questions, let me know. Intentionally, I'm giving only 1 hour because I don't want to put so much in a short time, which will be hard for you to digest. Okay, revise everything. This is our fourth session. We have completed the most important very nicely. We are coming from the scratch, covering each and everything, traveling for Spark. So spend your time on that. If you have anything, let me know. But that's all I have for today. Any questions, give me a shout. Any questions?
Anna, this is Raman.
Yeah, go ahead, Anna.
హలో నా ఫిల్టర్స్లో మీరు మంత్స్ చెప్పారు కదా,
Okay.
ఆ మంత్స్ దగ్గర మీరు ఎస్సీ డాట్ ప్యారలైజ్ మంత్స్ అని పెట్టారు కదా, ఆర్డిడి మంత్స్ ఈక్వల్ టు ఎస్సీ డాట్ ప్యారలైజ్.
అవును.
అక్కడ ఇందాక ఎక్స్ అని పెట్టారు. శిల్ప గారు అడిగారు శిల్ప అని పెట్టమని. ఐ మీన్ శిల్ప పెట్టారు కదా మీరు. మంత్స్ అని కూడా పెట్టచ్చు కదా.
Even but see, initializing a variable is up to you. You can do anything.
Okay.
It's just if I give Shravan will be applied for this one, Shravan applied for this one, Shravan applied for this one, for this one. Like that, it will be a variable will be assigned a variable, and its function will be applied on this one, on this one, on this one, on this one, on this one. That's it. Okay.
Okay.
Have a good day. Enjoy your work. I'll see you tomorrow. Thank you, guys. Cheers.